Hi, welcome to another lesson of Overworked Linux Admin. I'm your host, Zach, and today's lesson will be about system monitoring. We'll be both looking at both PS and TOP to help us understand a little bit more about how our server operates. Diving right in, we're going to be taking a look at PS. PS is useful for us finding out about specific processes and what they're doing. With the proper options, it can be very powerful and give you a lot of insight into what is going on in your server. For example, if you were kind of wanting to take a look at what users are doing, you could do ps-u, and then you could do, I think I have root in here, that'd probably be, you can see what's running as root, or you could do PSAFX, which shows you a tree view of all the processes. As you can see here, you have GNOME session and everything that's running under that, so you can see I'm doing a lot of stuff there. Um, so that provides a tree view. What you could also do is do a PS tree. It gives you a lot of the same information, but just not as clean. That's why we're using PS. Now, one of the most useful switches with PS is doing PSAUX. Now, what that does is that shows you a ton of usage information about those processes, like the PID, how much resources they're taking, how much memory they're taking, what session they're at, when they started, and what command is being run. So it can show you a lot of different information, and you can even, do, if you want to see if a specific service is running, you could do, let's just say HTTP. I don't obviously have that running, but if I want to do, let's say PSOX, want to see all the bash sessions that are running, you can see here I have a number of different ones running here. So So that's a very convenient way of just taking a quick insight into the processes that are running. So moving on into top. Top is a convenient way to monitor current process activity. From that interface, you can do some basic job management tasks, which we'll cover in the next lesson, such as killing processes or reprioritizing them. So this is top right here. So you can see here that there is a ton of information. The first line here tells you a little bit about, your server. It tells you the uptime, what time it is, how many users are logged in. I'm logged in here a bunch, and it tells you the load average split between 1 minute, 5 minute, and 15-minute polling intervals. As you can see here, I'm not running a lot of load on here. So the rule of thumb for the load average is that the number should never be higher than the number of CPU cores on your system. So if you have 6 cores, then having this as a 6 would be fine. If you don't know the number of cores, you could always do cat/proc CPU info, and that will tell you the number of cores. As you can see here, I'm only running 1, so if my load average is at 2, then I have 2 processes that are currently queued to be processed by my processor. So that means that there's some significant wait time on my system. So that's the first one. The second line here, it shows you the total running tasks, or the total tasks split between the running, the sleeping, the stopped, and the zombie. Now, I go into further detail on my site, but the ones you're really concerned about are the zombies. That means that the parent process was killed, and all the child processes under that can't be managed. And because they can't be managed, you can't really kill them unless you reboot it. And so they just stick around and they take up resources, and that just slows down your server, and it gets a lot of different errors. So that's the one we're concerned about the most. The third line here is the CPUs broken down into the different spaces. We have the user space, which is everything that we're seeing within this that we can interact with. We have the system space, which is the kernel space, everything that the kernel does. We have the any process that's been reniced or reprioritized, which we'll get to in the next lesson. We have idle. We have wait. This is actually kind of important. If this is high, then that means there might be some performance issues, particularly with your disk I/O performance. So if that's high, you might want to take a look if there's an issue with your drive or your file system or anything that could be affecting your read-write times. Then you have your hardware interrupt, you have your system interrupt, and then you have your CPU stolen. This you really won't see unless you're running the Linux server as a hypervisor host like KVM. So you really won't see this too often at all on a web server. So there's that. And then these last two lines here are just about your memory and your swap space usage. So you can see here the total memory and swap in kilobytes. You have it in you have the total memory used. Then you have what's left free, and then you have your buffers, and then which is also your cached. So that's basically top in a nutshell. Another couple of things that you could do to look for system resources is you could do yum install sys stat, and this is just a real quick off the topic here. So you just do yum install sys. I already have it installed, so I can show you sar-q. And what this does is sar keeps track of your system states over like in this case over the past 24 hours. So you can see here my load averages since 12 a.m. It hasn't really changed much since then, but you can see the 1 minute, the 5 minute, the 15 minute. So that's one way to take a look at the different resources that are being used on your machine. So like sar-S shows you your swap space, and then I believe it's lowercase r shows you your memory used. So those are kind of a quick and dirty way to take a look at your system resources. So that concludes this chapter of Overworked Linux Admin. Stay tuned for the next chapter where we talk about resource management.